All right, welcome everyone to another Sunday morning session for Victorian Selective School Maths preparation. So today we are going to pick up a very interesting topic. Not sure how many of you would have introduced this one, but it's a very important topic, not just for Selective School exam, but in general for life, right? In general, that'll you will use from pretty much grade 7 till grade 12, right? Now, the topic that I'm going to introduce you today with coordinate geometry, Cartesian plane, and two variables, and probably something called linear relationships, right? So this is a very, very big topic, right? We might not be able to finish this topic in 1 hour today. So if not, then we will continue even next week as well, right? Now, again, no spamming on chat. And if you can quietly listen, that'll help all of us, right? And I don't want people to be pushed back into the waiting room, right? All good, cool. So, what we've done so far in the world of algebra, and we learned linear equations. And when I said linear equations, that means you were able to solve any equation in one variable. So, for example, if I say 2x equals to x plus 5, and I say solve x, so you will say, okay, 2x take away x equals to 5, and therefore x equals to 5. Cool. This equation has got only one variable in it, one pronumeral, which is x. So this is called equation in one variable. Equation in one variable only, which is x. Now, let's write something in two variables. So the two most commonly used variables in general in algebra are x and y. Now, if I say y equals to x plus 5, now what I've done here is I have written an equation, and I tell you what is an equation. Equation is something that has an equal to sign in it. So this is an equation. Now this equation has two variables, variable x and variable y. Now we can play around with this as much as we can, as much as we like. How do we play around with it? If I say x is equal to 1, then what will be y? Can you tell me? Just testing your understanding here. All right? Don't worry, I'll do it. Good. 6. What exactly we've done here is we have substituted. We have replaced x with 1 in this equation. What I've done is x has been replaced by 1. So wherever there is an x, I've swapped it with 1. So I say 1 plus 5, which makes it a 6. So y is 6. Now, if I say y equals to negative 2x, and I say x equals to 2, can you tell me what is y? We're doing linear relationships, Shaban. Negative 4. Good job. So what we've done is we have swapped 2 with x. So it is y equals to negative 2 times 2, which is negative 4. Now, what if I say x equals to negative 2? Then what is the answer? Anyone who has not got this, can you let me know in the chat? This is the simplest of the simplest that we can go to in order to understand two variables. Ishita, it's not y, it is 4. So I think that you must have written it by mistake. So what we've done is we have swapped x with negative 2. And negative 2 times negative 2 is a positive 4. So the answer is 4. Now, let's go to the next page. Please travel along with me. All right. Now, y equals to 2x. This is an equation which has two variables, x and y. This equation, can you tell me what is the degree of this equation? I repeat, what is the degree of this equation? I don't see many answers coming in here. And this is where revision comes into play. You know, this was the very first topic that I covered, week 1, degree. Degree means what is the highest power of any variable in a particular equation. I have two variables, x and y. Now, can you tell me what is the power of x? The power of x is 1 because I can write x as x raised to the power of 1. Similarly, the power of y is 1. I can write y as y raised to power as 1. So degree of x, the power of x is 1, the power of y is 1. So out of the two ones, which is the higher number? Obviously 1. So the degree of this whole equation is 1. The highest power of any variable in a particular expression or equation or even term. So, sorry, I'm now digressing a bit from the topic. So if I write 2x square plus y equals to 5, then I have two variables, x and y again. What is the power of x? The power of x is 2. What is the power of y? The power of y is 1. Which out of the two numbers is a higher number or a bigger number? It is 2. So the degree of this particular equation is 2, the highest power of any variable sitting in that expression or equation. You getting my point now? Yes or no? So that's the degree. All right. So now coming back. Let's change the color. All right. Now look at this. Color didn't change, surprisingly. All right. Let's look at this now. Y equals to 2x. Now, what is the degree of this equation? The degree of this equation is 1 because that's the highest power. So any equation or an expression which has a degree equals to 1 is called linear equation or linear relationship or linear expression, depending upon what you're dealing with. So this y equals to 2x is a linear equation or a linear relationship. Why do we use the term relationship here? We use the word relationship here because there is a relationship between y and x. If I ask you plug in x equals to 1 and give me y, you will say y equals to 2. Why? Because 2 times 1 makes it a 2. So you established a relationship. You entered x and you got the output as a y. X is 1, y is 2. Now if I say x is 0, y is, if x is 0, y is 0 simply because y equals to 2x. So I'm swapping x with 2 with 0. 2 times 0 makes it a 0. So we have a relationship here. X spitting out y. You enter x, you get y. And I can do vice versa as well. But to keep this explanation simple, x is giving me y. That is why it is called a linear relationship. I see 39 students following my whiteboard and there are 40 kids here. One is still not following me. So if you're not, I'm on page 2 and I'm now going to go into page 3. All right. Linear relationship. These are called relationships. So since they're the relationship between x and y, and since they are 1-degree equations, the relationship is called linear relationship. Now, linear relationships are very it is the most common relationship that we see in real life. You have been using this from the day you are born until today, till the time you are on this earth. Linear relationships, we are surrounded by linear relationships. A common example is you go to a candy shop and you liked one candy and the cost of one candy is $2 and you, let's say, have picked up 3 candies. So the total, you've picked up 3 candies. So what is the total cost that you have to pay for 3 candies? $6. Absolutely. So what you've done is $2 times 3. So it is $6. Now your sibling comes in and they pick up 5 candies. How much would they pay for 5 candies? So $2 times 5 makes it $10. And you see now here, there is a relationship. There is a linear relationship that's sitting underneath. Total cost is equals to 2 times the amount. Let's say the number of candies, and I can call that number of candies as, I can write number of candies. So that, and if I call the total cost to be y, and I call number of candies to be x, y equals to 2x is what the linear relationship is. Last warning to people here, L for Sonic, Shaban, admin. Last warning, any spam that I see from now, you'll be pushed out straight away. Last warning, right? You'll be missing a good 40 minutes from now. I've called the names out and I'll just do a name and shame now, okay? All right, cool. Now, you'll be pushed out without even any warnings. All right, you're disturbing me here and everyone. All right, cool. Let's go to the next page now. I'm on page number 4. All right, now let's see how we can represent the relationship on something called a Cartesian plane. Have you heard about this word Cartesian plane? Anyone? Good. It is called coordinate plane, Cartesian plane. So let's quickly talk about it. People who don't know. I draw a big plus sign, and this has two lines. The horizontal line is called the x, and the vertical line is called the y. X and y. Now in this world, it's called x axis, correct? And this is called y axis. Now, this world of Cartesian plane is divided into 4 regions. I call it as region 1, region 2, region 3, and region 4. They're not called regions, but they're called quadrants. Quadrants. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now, we follow an anti-clockwise direction here when we are going 1, 2, 3, 4. We don't follow the clockwise rotation. So that's how you remember. It is an anti-clockwise rotation. All right, now let's talk about quadrant 1 only. And I'm going to the next page now. Okay. Quadrant 1. Each quadrant or each axis in a particular quadrant is scaled. So when we say scaled, so which means at this point here where both the quadrants meet each other, It is the starting point and is marked as 0. The starting point or the 0 is also called origin, the starting point. Now I scale it sequentially. So this will be 1, 2, 3, 4, 5, and I can go on and on and on, right, up till infinity. Now, similarly, I scale the y 1, 2, 3, 4, and so on. This is the x, and that is the y. Now, this is the first quadrant. Now, at any given point in time, we represent the position of any particular point in terms of its coordinates. So for example, if I put a point here, this is represented by a set of coordinates x, comma y. That tells me the position of this point in the first quadrant. Position of the point in the first quadrant. So if I look at it, what's the position of this point on the horizontal axis? So which is, if I just do like so, this point on the horizontal is 2, and so x is 2. What is the position of this point vertically, which is 1? So the position of this particular point is 2, comma 1. We always write the x followed by the y. We don't write it other way around. So it's 2, comma 1 is the position of this point on the coordinate, on the Cartesian plane. Anyone who has not got this stuff before I move on? Anyone who didn't understand this? All right. All good. Now, next one. So I am going to throw something here now for you to quickly tell me, the position of various coordinates that I'm going to ask you. Okay, let me just pull out something, my snip tool. Uh, okay, I'm pasting something here now, and we'll understand it using this. Can you tell me the position of point A on the Cartesian plane? Give me the coordinates of point A. Hmm. 3, comma 1. Good job. Give me the position of point B. Point B. B is 1, comma 3. A few of you see B here. B is 1 because that's where B is, horizontally, and 3. So this is 1, comma 3. Don't write 3, comma 1, please, okay? Now, can you give me the position of C? 0, comma 4. Good job. Can you give me the position of D? 1, comma 1.5. Good job. Good job. So far, so good. All right. Let's go to the next page. So you're getting it. Great. All right. I'm on page number 6 now. Now, let's say you have, now I'm not going to give you the Cartesian plane, and I'm going to give you just a question regarding that. Right. Let's say there is a coordinate A, which has the position 2, comma 5 on the Cartesian plane. That means x is 2, y is 5. If I move this, if I move this 2 units on x, what will be the new position? All right, I'm just reading through. All right, I think none but only Joydeep asked the right question to me. Left or right? I did not mention here. Where have I moved this? Let's understand this. I am at 2, 5. So this is 0. Let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is y. This is x. 1, 2, 3. 1, 2, 3, 4, 5. Now, where am I? 2, comma 5. I am here. That's my point. 2, comma 5. I said I have moved it 2 units on the x. Now I could have gone here. I could have gone here. No one really bothered to ask me. So on the Cartesian plane, it is very important. On the Cartesian plane, it is very important. Where are you moving? If you are moving in the x, if you're moving horizontally, you need to be either moving on the right hand side, right, or left. So if I say I have moved 2 units on the right, then if I change the color, I am here, I have hopped 2 units. So I am sitting here now, which is 4, comma 5. If I would have moved on the left hand side, I would have sat here, which is 0, comma 5. So don't just blindly jump the gun. It is important to understand when you are moving on the Cartesian plane, where are you moving? Left or right if it is horizontal. Now, I give you another question now. Same coordinate, a equals to 2, comma 5. Now I have moved 1 unit on y-axis. 1 unit on the y-axis. What is my new position? Can someone tell me my new position? Thank you very much. Very, very important to ask. Up or down? Let's say down. Now give me the new position. 1 unit down. 2, comma 4. Absolutely. What I've done is I have come down by, so now I am here. And this is 2, comma 4. Okay. I ask you another question now. I have moved. I have moved 2 units on the right and 1 unit up. Give me the new position. I am at 2, comma 5 still. 2 units on the right and 1 unit up. Is there anyone who's not clear with this basic concept? Yes, it is still point A. Kartiki, yes, it is. We are still dealing with 2, comma 5. So we are now 2 units right and 1 unit up. So now what I'm going to do is 2 unit right means add 2 to the x. So my x is 2 and I add 2 to it. And my y is 5 and I add 1 to 5. So the new position is 4, comma 6. Now if I have moved rather than a 2 units right, I say I'll change the color. 2 unit left and 1 unit down. What is my new position? 2. I'm still using 2, comma 5, my original position. I am now 2 units on the left, 1 unit down. Zero, comma 4. Good job. So what we've done here is to my original position 2, comma 5, I have moved 2 units left. So that means 2 minus 2, comma, it's a negative 2 now. You see here, negative 2 and positive 2. When you're moving left, it is negative, you're decreasing. When you're moving right, it is increasing. And 1 unit down. Down is negative, up is positive. So 1 unit down would mean I am 5 take away 1. So I am at 0, comma 4. Cool. That makes sense. All right. Let's go to the next page. We certainly need one more lesson to knock this off. All right. Now, I have a rule y equals to x plus 1. Let us try to represent this rule graphically. That means I'm going to draw a rule on the Cartesian plane. This is a linear equation. Okay, now this is x, this is y. Okay, now quickly, in order to draw any particular linear equation or a linear relationship on a Cartesian plane, you need some coordinates. And this relationship will help us generate some coordinates. Tell me when x is 0, what will be y? Why on earth is someone said a 0? X is 0, I'm plugging in 0 here. So 0 plus 1 will make it 1. So y is 1. Let's plug in x equals to 1. What will be y? 2. Good. Let us try to plot these 2 points and see whether we can do something about it. Can we draw a graph? Let me label it quickly. 0, 1, 2, 3, 4. 1, 2, 3, 4. Let's change the color. 0, x is 0, y is 1. X is 0, y is 1. That's my point. X is 1, y is 2. You see here, x is 1, y is 2. If we join the dots, not a perfect connection, sorry about that. You see here, I can extend this. I got a straight line. I got a straight line. Now, I just plotted 2 points and I've drawn a straight line. So what we've learned here is that in order to draw a straight line, in order to draw the graph of a linear relationship, a 1-degree relationship, you only need 2 points, minimum. You need 2 points and you connect them and you get it. That's about it, and you can extend it. Now this graph, I mean, though this is not a perfect one because I've drawn it from my hand, but still try to sort of, learn. If I don't know this rule, for example, I forget this. I am not aware of this now. Forget about this for a second. And now I have just given this graph. And I'm asked that, okay, when x is 3, what is y? So what I'll do is I'll go to x equals to 3 and I probably draw a straight line which will hit the line, my graph, and I'll just correspondingly read the y value. So when x is 3, y is 4. Now let's come back to this y equals to x plus 1. Plug in x equals to 3, you get a 4. So you see what's happening here, that graph helps us to find the relationship between x and y, even if we don't know the original relationship. Is this point clear to everyone? How I have used the relationship to draw the graph, and how I have used the graph to find the relationship. So we can use it either way. All right, and we also learned that in order to draw a graph for a linear relationship, we just need 2 points. Now, I'll change the color and not go to the next page. We'll stay on this page still. And I'll change the color. Let's go black. Now, can you tell me the relationship that you have here, y equals to x plus 1? Can you tell me, so far what we've done is we have given x as an input and we got y as an output. Now, what we are going to do is we are going to give y as an input and get x as an output. We can do either ways, not a problem. It is just a rearrangement of the linear equations that we've learned, right? So if I have y equals to 0, can you tell me what is x? Y is 0, what is x? -1. Yes. If you don't understand why, let's quickly do it. Sub in y equals to 0, y is 0, x plus 1. And leave me alone strategy, if you remember that x has positive 1 sitting with it, so I'll take away 1 on both the sides. So 1, 1 gone, x equals to -1, so -1. Now let's quickly see, where is this sitting on the graph? Y being 0, that's the point here. That's -1. Now what we've seen is, all of a sudden we have come to the second quadrant from the first quadrant. We've gone past the boundaries of the first quadrant. Now if I say y is, let's say now if x is -2, can you tell me what is y? X is -2, what is y? -1, absolutely right. So what we've done is, we've plugged in -2, got -1. Let's quickly find where exactly is it on my graph. X is -2, so if this is -2, that must be -1. That's the point. -2, comma, -1. We have slided into the third quadrant here. We've slided into the third quadrant. I know it's become messier, but if you're following me, you should be fine. Now, I ask you another question. What if my, so this is -1. Now, what if my y is I'm thinking. Let's say if my y is -5, what will be x? -6. Good job. Good job. All right, cool. Let's go to the next page now and summarize what we've just learned. So, if I draw the Cartesian plane again, what you just saw was in the first quadrant, your x was a positive and your y was a positive. So +1, +2, +3, +4. So any coordinate, so for example here, this is 2, 1. Both x and y are positive. In the world of second quadrants, if I've got this point here, this is -2, 1. So x is negative, y is positive. This is the second quadrant. And I write x as -x here. I don't write it as x here itself. Now, negative tells me I'm on the negative boundary. Third quadrant. Let's say this is -1, -2. This point here. This point is -2, -2. So in the world of third quadrant, my x is negative and my y is negative as well. And I write the bottom part of my horizontal equation, of my vertical line, exact y-axis as -I. And in the fourth quadrant, what is this point? This point is 2, -2, which means your x is positive and your y is negative. This is your fourth quadrant. So the Cartesian plane behaves, the first quadrant, both of them are positive. Second quadrant, x is negative, y is positive. Third quadrant, x is negative, y is negative. Fourth quadrant, x is positive and y is negative. Anyone who's not got this concept? Simple and straightforward. Now, let's go to the next page. What we are going to do now is we are going to learn something called the intercepts. Now, x is positive, x is negative, y is positive, and y is negative. We just learned that, right? Now, let's draw a straight line. Let us say the same straight line, y equals to x plus 1. So when x is 0, y is 1. When x is 1, y is 2. Let's do that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Let's do, take a different color. X is 0, y is 1. That means that's my point. X is 1, y is 2. That's my point. Let's draw a straight line. Kind of, yeah, yeah. All right. Now, Let's understand the terms intercepts. Intercepts are those points where the graph or your straight line meets x or y axes. It's a very important concept. Those of you know can keep quiet, and those of you don't know, listen. Intercepts are those points where your line meets the axes. Now let's take a different color here to see this red line. Where is this red line hitting the y-axis? At this point here. And what is the y-coordinate? The y-coordinate is 1. The vertical measure of the y-coordinate of this point is 1. So since this red line is meeting the y-axis at 1, so my y value is 1. And I call this as the y-intercept. The y-intercept. What are the coordinates of this point? The coordinates of this point is 0, 1. Can you tell me what is the x-coordinate of this particular point? The x-coordinate. So the x-coordinate is 0. So the point that we've learned is that the y-intercept has x equals to 0 always. And that is why it is called y-intercept. So 0 is not the answer. 0 is the answer for the question that I asked, that where is this point meeting, what's the coordinates of x? But we are learning y-intercept. Now, the way y-intercept makes x as 0, similarly, your x-intercept should be doing the same, but opposite. It should be making y 0. So x-intercept is that point on the red line, on the straight line, where the line is meeting the x-axis. Where is the line meeting the x-axis? Here. And that is -1. That is -1. So what are the coordinates of this point? The coordinates of this point is -1, 0. So your x-intercept is -1. So the points that we learned quickly here were the definition of x-intercept and y-intercept. Now we use the graph to find these y-intercepts and the x-intercepts, or these intercepts. We actually don't need the graph per se. If I go to the next page and the last page, I might go overboard by like a minute or so. If you can hang around, that'll be great. If you, those who want to go, feel free to leave, right? Those who are interested in learning can continue. So if I have a line, if I have a graph y equals to x plus 2, let's say, y equals to x plus 2, and I'm asked to find the y-intercept. What I need to do is I just need to make x as 0. I just need to make x as 0. So when x is 0, y is 0 plus 2 is 2. So my y-intercept is 2. Similarly, if I want to find the x-intercept of this particular rule, I make y 0. I say 0 equals to x plus 2. And I take away 2 on both the sides, and x equals to negative 2. So x equals to negative 2 is the x-intercept. So now today, what we have, we'll finish it off here. So we learned a very important concept of x-intercept and y-intercepts with or without looking at the graph. Now next week we will continue to learn gradient, and we'll sum all this up and we'll do some real life application questions next week on this particular topic, right? Before we knock this off, right? And yes, we'll learn y equals to mx plus c and all that stuff. Right? All good, cool. Thank you very much, Arav. Here, I'm calling you out. Probably, I'll not let you in next week, right? You've spammed enough today, right? All good. Thank you very much, everyone, today for the wonderful time. I hope you loved this session as always, and I'll see you back next week. Thank you.